Probabilities. We're going to look at some terminology first. Disjoint events and mutually exclusive events are used interchangeably. And what that means is that we can have two different events with no outcomes in common. So let's say that event A is the outcome from rolling a die. Well, the outcomes from rolling a die are 1, 2, 3, 4, 5, and 6. And let's now say that event B is flipping a coin. So the outcomes from flipping a coin are heads and tails. These would be considered mutually exclusive or disjoint events because there's no common outcomes between the two. So these are mutually exclusive or disjoint events because there's no outcomes between the two. If we wanted to find what the probability of event A or event B happening are, we simply would add the two together. Here's an example. A card is randomly drawn from a standard deck of 52 cards. What is the probability that it is a face card or a 10? So the first thing we need to identify is we're going to say that the probability of event A is a 10. Well, we have 4 different outcomes. 1, 2, 3, 4. And the probability of a face card are the 4 kings, the 4 queens, and the 4 jacks. Now notice that there's no common outcomes between the two different events. Therefore, we can simply add them together. So 4 out of the 52 cards is event A, 12 out of the 52 cards is event B. We add the numerator and simplify, so the probability of choosing a 10 or a face card is 0.308. Now in some cases we can actually have overlapping events, and that means that we have one or more outcomes in common. So let's say that our example is event A is the probability of a brunette, and event B is the probability of blue eyes. Now we can have brunettes that have blue eyes. So if you want to think of it like this, where this is event A and this is event B, we can have the brunette, we can have the blue eyes separately, but we can also have some people be a brunette and have blue eyes. Now, why this is important to identify if events are overlapping or not is if we're going to find the probability of a brunette or the probability of blue eyes, in the first case we would add the two together. But in this case, when we add the two together, we're adding the number of people, in this case, that are brunette, and then we're adding the number of blue eyes. But some of those people have been counted twice, and that's the people who are brunette and blue-eyed. So in example 3, we're going to use an equation where we have overlapping events. So we have 200 total students that are seniors. 113 are either varsity athletes or on the honor roll. So they're one or the other. There's 74 seniors who are varsity athletes and 51 that are seniors. What is the probability that a randomly selected senior is both a varsity athlete and on the honor roll? So let's look at our equation. We can say that event A is the varsity athlete and event B is the honor roll. So we have to count how many people are the varsity athletes, how many people are the honor rolls. But then we have to subtract the people who are double counted, where they are both varsity athletes and honor roll. So let's sub in what we know. So we have that 113 are one or the other. So 113 out of the 200 are one or the other. Then the varsity athletes is a 74 out of 200. The seniors who are on the honor roll are 51 out of the 200. So what we're trying to find is the probability of A and B. So what we've done is we've created an equation that we can rearrange and solve for the probability of being a varsity athlete and on the honor roll. So we can subtract 74 and 51 from both sides. So we get negative 12 over 200, which is negative the probability of A and B. And the negatives on each side cancel, so we get 0.06. The complement of an event consists of all of the outcomes that are not included in the defined event A. So for example, if we say event A is rolling a die, but specifically rolling an even on a die. So that means that event A has the outcomes of 2, 4, and 6. A bar is how we verbalize that, would be all of the other possible outcomes that are not included. So that would be 1, 3, and 5. Together, the two probabilities of an event plus its complement has to equal 1. So in this case, we would say that event A would be 3 out of 6, the complement would be 3 out of 6, and together they would equal 1. When two six-sided dies are rolled, there are 36 possible outcomes, as shown to the right here. Find the probability of the given event. So the sum is not 6. So there's two different ways we can do this. We can just say, okay, let's actually look at all the outcomes and count up how many are not 6. Or we can look at it and use the complement by saying, well, to find the probability that the sum is not 6 is equivalent to 1 minus the probability that the sum is 6, because they're complements, so together they have to add to 1. So how many are actually 6? We have 6 here, 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 and here. 1, 2, 3, 4, 5. 5 out of the 36 actually have a sum of 6. Make a common denominator. So we get 31 out of 36, which is approximately 0.861. So the probability of not getting a 6 would be all of these other ones. Now, yes, when we have a display in front of us, we can count them up, but it's not always going to be that simple. Now let's look and see if the sum is less than or equal to 9. So we're saying find the probability that the sum is less than or equal to 9. So we can either count up all of the sums that are 9 or less, or we can say that it's 1 minus the probability that the sum is greater than 9, which is a smaller number. So if you look back at your table, the display, it's actually 6 out of 36 that have sums that are greater than 9. Make a common denominator, and we end up getting 30 out of 36, which simplifies to be 5 over 6, and approximately 8.33.